Hello everyone, welcome to our pre-calculus pre-recording video. This is the last video before our quiz 2. So quiz 2 is coming up. Our next in the next class we have the quiz 2, and we will send you all the preparation slides also, so that you have the idea about the setup for the quiz 2. So, and we will try to send it a little bit earlier now, so no worries about that. For this class, we have the topic here, finding the equation of a secant line and the library of functions. These are the agenda: average rate of change, secant line, then practice on the same topic, graphing the functions from the library of functions. Basically, these three topics is same, this and these two topics is somewhat same. They are interrelated. Okay, let's look so that you all have some idea. So this is an idea, this page, this slide is just to build your idea. What is a secant line, or what we are going to do here, or how this secant line is connected to other topics. Some of the topics that we already discussed. Suppose you already know about the slope. You already know about the equation of a straight line. So how that is related here. So let's have a look. This is the average rate of change. Average rate of change means slope. But you see, let me first of all bring everything. Slope, you can find out the slope of 2 points when the points are given in some coordinate system. Then you have this point and this point. Some point is x1, y1, some point is x2, y2. Then you can use the formula y2 minus y1 divided by x2 minus x1 to find out the slope. Okay. But what about this curve? Now this is not a straight line. Slope we find for the straight line. We find slope for the straight line. For the curve also, we can do the similar mechanism. We can do the similar thing. We can choose 2 points on the curve, and then based on that 2 points, we can draw a line, and then we can find out the slope for that 2 points. So we can find out the slope from that 2 points, and if we have 2 points and slope, then we can find out the equation of line. In this case, this equation of line will be called secant line. The reason is this is for the curve. And of course, you can say, sir, why the points are here? These are chosen, just chosen. You can choose the points here and here also. You can choose the point here and here also. Or we can choose that. Okay, we can tell you that, okay, if one point is here and one point is here, of course we will tell you the give you a hint about the coordinate of the point, so that you all can find it out. So this is how the secant line and the average rate of change is connected with the slope and equation of line. Let me recap. Slope and average rate of change is the same thing. Average rate of change and slope is the same thing. And secant line and equation of line is the same thing. Only difference is this is done for the curve. This is done for the curve. Okay, so this is the only difference. Let's look at an example in the next page. Gx equals to x square plus 1. First question is find the average rate of change from -1 to 2, and then find an equation of secant line containing the point this and this. So average rate of change from -1 to 2. These are the x value. These are the x value. Okay, that means we will have to put -1 here and 2 here. So if we put -1 here in the question, then what we get? For -1, g of -1 equals to -1 whole square. We are putting in x, then plus 1. -1 whole square means plus 1, then plus 1. That means this equals to 2. Let's write it here. That means this equals to 2. So see, when x equals to minus 1, y equals to 2. That means the point is minus 1, comma 2. This is a point. Now you got a point. See? Then this is also another x value. We will put it here. For 2 or for x equals to, you can write for clear understanding. For x equals to minus 1 and for x equals to 2. Actually, we can look at this also. This also means that x equals to 2. G of 2 equals to. Similar calculation, so let's not put some time here. 2, if we put 2 here, 2 square means 4, 4 plus 1 means 5. So basically it will be 5. And so the point is 2, comma, when you put 2x equals to, y equal to comes 5. So this is the extra task here. First, you will have to find out 2 points. When you find 2 points, then the other tasks are same as we have done for the topics related to our quiz 1, like the previous topics, like find the slope now and find the equation of line for these 2 points. Now this is very easy. So this task is like we will have to do it for solving A and B. Okay, this is not the answer of A and B. This is the thing that we will have to do to solve A and B. So now a number, average rate of change, as we said, average rate of change is just simply the slope. So the slope is what? y2 minus y1 divided by x2 minus x1. So 5 minus 2, y2 minus y1 divided by x2 minus x1. 5 minus 2 means 3, then 2 minus 1 means 3, so 3 divided by 3 means 1. That means slope is 1. This is the answer of A number. Slope is 1. Okay, this is the answer of A number. Now for B number, you have one very strong formula. We said that most of the time for finding the equation of this straight line, you will have to start with that formula, that is y minus y1 equals to m into x minus x1. So in this formula, this is the point slope form of the equation of the straight line. So here, if we put the value and the slope, then actually we will get the solution. So y minus y1, in this case we thought that y1 is 2. You can choose other point also, answer will be same, m equal to 1, x minus x1 minus x1 equals to minus 1, that means minus minus it will become plus, and then y minus 2 equal to x plus 1, then y equals to, this 2 comes to the other side, then it becomes x plus, this is 1, then this will become plus 2, so 1 plus 2 equal to 3, so this is y equal to x plus 3. This is the answer for our B number. They said that find out the equation of secant line. So this is the equation of secant line, and containing the point minus 1 and 2. See, this is for the minus 1. This is the point for the minus 1, and this is point for the 2. See, this is 2. This is minus 1. G of minus 1. We already found G of minus 1 equals to 2. Then G of 2. This is the value of G of 2. G of 2 equals to 5. So we followed all the conditions that they set. So yeah, this is how we find out the average rate of change and the equation of secant line when based on the given information. Okay. We have some practice maths here, similar kind of maths. You give a try. Now this is the question for drawing the graph, graphing the equation. This is fx equals to square root of x square root of x this is fx equals to square root of x. And for drawing the graphs, most of the time our one of the most important way to draw is to the very most classic way of drawing is actually think about some value of x and calculate the value of x. Okay, so let's say the value of x is 0, then what is the value of y? If you put 0 here, square root of 0 means 0. Okay, if you put 1 here, square root of 1 means 1. If you put 2 here, some answer will come. If you put that will be decimal, square root of 2 is decimal, square root of 3 is also decimal. So if we put 4 here, then answer will be square root of 4 means 2. If we put 9 here, then square root of 9 means 3. Notice that we are putting 149 because square root of these numbers are possible. Now you can say, sir, what if I put some other numbers? Answer is you can put, in that case that will come decimal. Let me show one point. Suppose if we put 2, what will happen? If we put 2 here, then square root of 2 means 1.41. So basically 1.41 is a decimal number, so it's tough to put the decimal number accurately in the coordinate system. That's why we usually, and this is also actually some irrational number, we just approximated it here. So we usually avoid this kind of decimals if we have the scope. In this case, we have the scope. Okay, now let's put some negative number. So minus 1. If we put minus 1 here, minus 1 is square root of minus 1 is undefined. That means there is no answer here. Square root of minus 2, same, that is also undefined. That means in the negative side there will be no graph. Okay, now let's plot it. 0, 0, 1, 1. For 2, we found this value 1.41, so the point will be somewhat here. For 4, it is 2. 4, it is 2. For 9, it is 3. 3 is here. And we could continue. 3, this is 9. After 9, we could choose 16, 25, 49, 64, 81, 100, 121, 256. This way, all the numbers will give you some answer, big answer here, little bit bigger answer. That means the graph will be something like this. Continued. So this arrow sign means we just stopped it here, but the graph is actually a continuous graph. So the graph actually starts from here somewhat, you can say, and then we have the graph only at one side of this grid, or even we can say that in the first quadrant only. The graph is not here, the graph is not here. And this method you can follow for all the graph drawing. Sometimes it is little bit lengthy. When you become expert a little bit step by step, there are some techniques, of course. Then actually you will be pro in terms of drawing without plotting the points. But this plotting the points will always work. This is the classic method, and this method will always work. And this is the best tool on this topic, graphing, that you will ever have. That's true, because some of the technique you may forget, but this method will hopefully will stay always. Okay, so this is how you draw, and drawing other graphs. Suppose if we write here x square and then this and that, everything will work this way. Okay, now let's look at the graph here. So see, this is the graph. And these are some common properties of this graph. What is the domain? The domain is from 0 to plus infinity. Range is also from 0 to plus infinity. From 0 to plus infinity, domain is also from 0 to plus infinity, because on the negative side there is nothing. It starts at 0 and goes to the positive infinity. Okay. The x-intercept is 0, y-intercept is also 0. This function is neither even or nor odd. Because to be even function, it has to there must be something in the to get an even function, it has to be y-symmetric. There is no y-symmetry line. It has to have something like that there. So that is not given. And to get origin symmetric odd function, it has to have something like that. It's not also here. So this is how we know that this is not even, not odd. The function is increasing on the interval from 0 to infinity. So you see, from here to infinity, the graph is increasing. As you know, if you start from the left side, then you start walking, the graph is actually increasing. For increasing, decreasing, and constant, the technique is start from the left side, then you move. Just look at where you move. If you move up, that means it is increasing. If you move down, that means the graph is decreasing. In this case, it is increasing. The function is increasing. The function has absolute minimum at x equals to 0. So this is the lowest point of this graph, and we can say it for absolute certainty. We can say it for absolute certainty because there will be no other points below this point. So this is the absolute minimum point of this point. Okay, but for maximum we cannot say it because that goes to the infinity. Okay, it has an absolute minimum there. So these are the properties. So see, from one graph, actually, we understand a couple of things. We understand a couple of things from one graph, and these are this. Yeah. This way, we will have to understand the graph. Yeah. This way, we will have to understand the graph. And this is just an example for other graphs also. Let me show you another one. This is the graph of cube root of x. So if you draw it, if you take some points for, suppose if you take 0, 0 will come, 1 by 8, 1 by 2 will come, like this way. Then you plot it, this is cube root of x, then you get some properties. This graph is, suppose the intercept is 0, 0, and the domain is all real number, range is all real number, then graph is symmetric with respect to origin, that means it is odd function, the increasing from the minus infinity to plus infinity, because you can set yourself here, you can start yourself here, and you can see the line is increasing forever. The function doesn't have any local minima or any local maxima, so we have all these properties here. To get a local minima or maxima, you will have to have that increasing and decreasing part in between. That is the reason. So this is how you can draw. This is the modulus of x graph. This is the modulus of x graph when x equals to 0, fx equals to 0, 1, 1, 2, 2, 3, 3. And then let me show you. This is for negative side what happens. If we take a negative 1, then modulus of negative 1, modulus. This sign means whatever you have inside this sign, you have to make it positive. So it is positive because modulus means the distance. That's why. Minus 2. If we put minus 2 here, then minus 2 comes here, then this equals to plus 2. So even if you put minus 2, answer comes plus 2. Even if you put minus 1, answer comes plus 1. Even if you put plus 1, answer is here. Okay, so this way we can draw. And similarly, this is actually even function. As you can see, it has symmetry with respect to y-axis with respect to. Domain is all real number, ranges from 0 to plus infinity, x-intercept, y-intercept at 0, 0. The graph is symmetric with respect to, already we said, the graph is increasing. From 0 to plus infinity it is increasing, and from minus infinity to 0 this is decreasing. See, you here, so you go down, that means it is decreasing. But here, you go up, that means it is increasing in this side. Then we have an absolute minimum at this 0. So these are the properties of the graph. Now you can say, sir, do we have to, or you will have to memorize these properties or not for the exam? Answer is no, you will not have to memorize this. These are the things that you should know, we should know to understand the future classes, okay, and to understand the future content, okay. This is the thing. But one thing you should know, suppose if we ask you what is the modulus of x graph, you must know that this is the modulus of x graph. Let me show you all other graphs. These are the graphs that you should know without drawing. Now you can say, sir, do we memorize? No, you draw it couple of times, then you will automatically understand that, oh, x square graph, because they are completely different from one another. You understand? This is equation of a straight line going through the origin, if x equals to x. This is some number, if x equals to b. This is a cube graph, square root of x graph. We have seen this one. We have seen this one, and this is x square graph. I think in some classes or in any previous video you have seen this as reference. Very important graph. In fact, all the graphs here you see in this page and in the next page, this one, they are very important. They are kind of basic. They are kind of basic. So you all should know actually these graphs very well. Suppose if you write cube root of x, so what is the graph of cube root of x? Cube root of graph x is this and this. Then 1 by x graph is which one? So you think about that. You should be pro about this graphs. These are very important graphs for pre-calculus and for later you will see for calculus. Okay. And that's all for today's class. And thank you all. Thank you very much for, as always, like for your quizzes, for your midterms, and when is the midterm, when is the quiz, always refer to our syllabus, please, because we will always, as usual, we will always follow that. Okay. And syllabus date, the date is already written in the syllabus. Just you can have a look in the Google Classroom. Suppose if you are curious, let's say, sir, when is our midterm? You did not say it, but it is already written there. Okay, so it's just you can have a look. And we will always, if there is nothing exceptional, like very big problem, if there is no big problem, then we will always follow the syllabus. Okay, that's our plan. And of course, for the quiz 2 also, we will send you all the revision slides. Then you will have the idea about the question pattern and all the detail about the quiz. So thank you all. Thank you very much. Have a good day, everyone. This is a homework review, like wire increasing, wire decreasing, odd, even, odd function, like that. Okay. You can if you already have solved it, you can match your answer and our answer from here. Alright, so thank you all. Thank you very much. Have a good day, everyone.